Okay, we're still going to be solving quadratic equations, and today we're going to move on to how to use factoring to solve quadratic equations, and this is my personal favorite method. We're going to be looking for ideas. So if I ask you just something like this, if x times y equals 0, could you draw any conclusions whatsoever from that before you cheated and look? No. I would hope that you would tell me, yeah, Mr. Schoberg, I know that if x times y equals 0, then either x must have to equal 0. Okay, I mean, I don't know for sure if x equals 0, but x could equal 0, or y could equal 0, or they might both equal 0. Okay, but I know that if x times y equals 0, one of those two numbers has to be 0. This is called the zero product property. The zero product property says for every real number a and b, if a times b equals 0, then a equals 0 or b equals 0. So one of those two numbers has to equal 0. Our question that we're going to be answering today is how could we use that zero product property to help us solve a quadratic equation like x squared plus 4x minus 6 equals 0. And I'm not sure we'll ever get to this exact one today, but if you want to go back at the end and see if you can solve that, that would be great. So we're going to see how we can use zero product property to solve quadratic equations like x squared plus 4x minus 6 equals 0. So let's start out with some that are like a little bit easier for us already. Okay, so here I'm going to solve this. The quantity 2x plus 3 times the quantity x minus 4 equals 0. Now you might be tempted in this case to start distributing everything out and putting this in standard form, but let me tell you right now, this is in the form you would like it to be. It's in factored form. The reason why I like this factored form is because we have two factors right now. We're saying that 2x plus 3 times x minus 4 equals 0. So we could look at it like 2x plus 3 is a, x minus 4 is b, it doesn't really matter, but one of these two factors has to equal 0 for this whole product to equal 0. So if I'm solving this, I would say, well, either 2x plus 3 has to equal 0, or x minus 4 has to equal 0. Because these two quantities are being multiplied together to give me 0, so one of these quantities must equal 0. Now we have something really nice and easy to solve. If 2x equals 3, then it looks like x equals 3 halves, or 1.5. If x minus 4 equals 0, then x equals 4. Okay, so x equals 3 halves, or x equals 4. Either of these values of x would make this equation true. They'd both make them equal to 0. So we could say x equals 3 halves or x equals 4. Both of these would be legitimate solutions to your equation, and you would need to include them both. Okay. So if I ask you to do this one, try this one on your own. So solve the quantity 3x minus 5 times the quantity 2x plus 3 equals 0. Again, I've got a product here, so this times this equals 0, which means that the values of one of those expressions must equal 0. So either 3x minus 5 equals 0, if I add 5, I'm going to get 3x equals 5, or x equals 5/3. If I do my second one, 2x plus 3 equals 0. Hey, that's the one I already just solved from above. Oh, I cannot believe that I put positive 3 halves for that. I hope you caught that. It was negative 3 halves. So subtracting 3 both sides there. 2x equals negative 3, so x equals negative 3 halves. Okay, so I've got x equals 5/3, or x equals negative 3 halves. Okay, again, you would want to write them both. All right, so that's the basics. We're going to use that to solve quadratic equations like that one I had shown you earlier. So we're going to call this solving by factoring. So if I give you something like this, x squared plus x minus 42 equals 0, the reason why this problem is not as easy as the ones in the past on the other slide is because we don't have a product here. We just don't have two factors that are multiplied together, so we can't just say, well, I think x might equal 0 or x squared or something, because that's not going to be true. So we are going to want to factor x squared plus x minus 42 equals 0. So conveniently, this is just a coefficient of 1 there, so I know that I'm looking for two numbers that multiply to negative 42 that add up to 1. So I'm thinking 6 and 7, and one of them is going to be positive, one's going to be negative. It should be x minus 6 times x plus 7 equals 0. Okay, x minus 6 times x plus 7 equals x squared plus x minus 42. So, I mean, if you weren't sure, you could always distribute that out and make sure, but it does. So we know here that because now we have two factors, either x minus 6 equals 0 or x plus 7 equals 0. If we solve each of these equations, this first one solves to x equals 6, and the second one solves to x equals negative 7. So my two solutions would be negative 7 and 6. Or I could say x equals negative 7 or x equals 6. Okay, let's try another one. It would be great if you can try this one on your own. Okay, so 6x squared plus 13x minus 5 equals 0. So we are going to try to solve this by factoring. And again, I'm probably going to guess and check a little bit here. So I'm going to try doing 3 and 2 for my 6. And I'm going to try doing 5 and 1. I can make 13 there, but only if they were both positive, and I need one positive and one negative. So I'm going to try switching my order and seeing if that helps a little bit. So I'm going to try, instead of 5 and 1, let me try 1 and 5. And then it looks like I make 2 here. 15. This is good if this is positive and this is negative. Okay, so it looks like this factors out to 3x minus 1 times 2x plus 5 equals 0. All right, so I've got my factors. That's the hardest part. The other part, using the zero product property, says that either 3x minus 1 equals 0 or 2x plus 5 equals 0. So if I solve this first one, 3x equals 1, so x equals 1/3. If I solve the second one, 2x equals negative 5, so x equals negative 5/2, or negative 2.5. So I have my solutions as negative 5/2 and 1/3. Okay, so those are my two solutions. X could equal either of those. All right, so you're going to see, yeah, I thought maybe factoring from chapter 9 was over, but oh no, it's not. Okay. So sometimes they aren't going to already be set to 0. I'm going to want you to write them in standard form and then solve it. So 3x squared minus 2x equals 21. To solve for the zeros, we have to have it where it equals 0. So I'm going to rewrite this by subtracting 21 from both sides as 3x squared minus 2x minus 21 equals 0. And then I'm going to try to factor it here. So I'm going to look for, I'll probably start with 3 and 1, and I'd probably start with 7 and 3. I'm looking at the cross products here. It looks like 3 times 3 is 9, 1 times 7 is 7. I can make that equal negative 2 if the 9 is negative. Okay, so I'm going to put the negative 3 here and the plus 7. So it looks like my factors are 3x plus 7 times x minus 3. That should equal 0. So again, set each part equal to 0. 3x plus 7 equals 0. X minus 3 equals 0. Let's solve these both. So this should be x equals negative 7/3. This should be x equals 3. It could be either one. Okay. All right. Try this one on your own, please. Okay. Then come back and check. All right, so I'm going to subtract 8x from both sides. I'm going to write it in standard form. So I know that x squared minus 8x plus 15 equals 0. And conveniently, this just has a coefficient of 1 there. So I'm just looking for two numbers that multiply 15, add to negative 8. That's negative 3 and negative 5. So I have x minus 3 times x minus 5 equals 0. So if either part of those equals 0, either x minus 3 equals 0 or x minus 5 equals 0. It looks like x could equal 3 or 5. Either one of those values. All right. One more, a little bit harder. All right. 5x cubed plus 15x squared minus 20x plus 3 equals 3. So I'm going to write this in standard form, and I'm going to try to solve it by factoring again. So I'm going to first subtract 3 from both sides, and then I have 5x cubed plus 15x squared minus 20x equals 0. But alert, alert, I've got a GCF here, so I want to pull it out. Okay, so this time 5x goes into everything, so I'll pull out 5x. And then I have x squared plus 3x minus 4, that should equal 0 for me. So I'm going to keep factoring. I'm looking for two numbers that multiply to -4 and add to 3, and I think that's pretty obvious that it's 4 and -1. So x plus 4 times x minus 1, that equals the middle term. I need to still have my 5x. Okay, what's different about this problem is now instead of having just two factors, you'll notice I have three factors. 5x times the quantity x plus 4 times the quantity x minus 1 equals 0. All right, so it wasn't explicitly stated in the zero product property, but I hope that you'd be able to see if a times b times c equals 0, then one of those three values, either a, b, or c, must equal 0. So this time we're either going to say 5x equals 0, x plus 4 equals 0, or x minus 1 equals 0, in which case x could equal 0, or x could equal -4, or x could equal +1. In this case, any of these values would work. So I'm going to say -4, 0, 1. Those are all values that x could equal. All right. So hopefully you're practicing some of these on your own and you're seeing if they're working. This last one is tricky. So here it is. Suppose that a box has a base with a width of x, a length of x plus 3, and a height of 1 inch. So here you've got your little box. It says it's x plus 3 by x by 1. And it's cut from a rectangular sheet of material with an area of 130 square inches. Find the dimensions of the box. What I think would be important to know here is like what kind of box we're talking about. So we're talking about an open top box, and you're folding it up from a flat pattern. So basically, here's like a rectangular sheet of paper that you're folding it up from. If you were folding it up right here on the corners, to get that height to be 1, each of those corners would have had to be like a 1 by 1 by 1 square. Okay, and then you would not actually use them as part of your box. Sorry. And then if you had the rest of your box here, I'll use a different color. This could be an x plus 3 for the length of the bottom of the box, and this could be an x. Okay, and then you'd have that 1. If you folded it all up, it would make your box. So the first thing to know is that the area of this is 130 square inches. 130 square inches. That's the area of my sheet of paper. But I'm trying to find the dimensions of the box, this rectangular prism right here. So important for me to note here is my entire dimension. If this side right here is x plus 3 of the box, and I also have a 1 here and a 1 here, it looks like this entire side would be an x plus 5. Okay. This side right here, if just the little part in here was x and I have another a 1 and a 1, this side is x plus 2. So I know that the quantity x plus 5 times the quantity x plus 2 should equal 130 there. Okay? And to solve this, I would get it all into standard form and set one side equal to 0. There's other ways too, guess and check obviously. So if I multiply these out, so I've got x squared, then 2x and 5x is 7x, plus 10 equals 130. And now I'm going to subtract 130 from both sides and say x squared plus 7x minus 120 equals 0. And I'm looking for numbers that multiply to 120 and add to 7. So I'm going to find that 8 times 15 with x minus 8 times x plus 15 could equal 0. So either x minus 8 equals 0, which in that case x equals 8, or x plus 15 equals 0, in which case x equals -15. Hopefully it's going to be kind of obvious for you that this is a box and x cannot equal -15, so x must equal 8. But the question asked me to find the dimensions of my box. So if x equals 8, this dimension is 8 plus 3 is 11. This dimension is 8, and this is still by 1, so it's an 11 by 8 by 1 inch box. Okay. All right, that's I know is definitely the trickiest problem. And there's another example I get in your book if you want to look back and refresh it on that. And I'll see you in class.